how to do a chi-squared goodness of fit test on your TI-Nspire. Let's get started. I'm using the M&Ms data here. In the first column, I have the counts of the different colors of M&Ms, and in the second column, I have the percentage that the manufacturer says we should expect for each of those colors. Now, in another problem, those percentages could all be the same if we would expect an equal percentage of all of our categories, but in this case, they're not. Now, I need to compute the expected counts. So the expected counts would be that 13% of all our M&Ms would be, I believe this was brown, 14%, whatever color that is, 13% red, 24% blue, etc. So what I'm going to do is I need to know the total count of all of my M&Ms. It's very easy to just add those up, but if you want to, you can go to any cell, put equal sum of, and then go to your variable button and pick M&Ms and push enter, and it will calculate the sum right there. So if you wanted it, I'll just do that. So what I need to do then is say equals, expected count equals the percents, notice they're in decimal form, times 58. This gives me all the expected counts. So if these were actually the percent of the various colors, then these would be the expected number of colors. Notice they are not exact numbers, nor are you supposed to round them. Okay, so in 58 M&Ms, we wouldn't expect exactly 7 or exactly 8, but 7.54 of the M&Ms to be brown. So we need to leave it that way. Now, once we have a column that has the actual counts or the observed counts and the expected counts, now we're ready to do a chi-square test. And we can do a chi-square test here in the actual column here of our spreadsheet. Now we can also do it on a calculator page, but there is an advantage in one or two areas to doing it on the calculator page. So let's go to Menu, Statistics, Stat Tests, and the chi-squared goodness of fit test, number 7. Now the first thing asks for our observed list, and that would be M&Ms. Then it asks for our expected counts, expected list, that's under expected counts, and then degrees of freedom. Degree of freedom is 1 minus, for the goodness of fit test, a little more complicated for the other two, but for the goodness of fit, it's just 1 minus the number of data cells we have in our observed list. And we have 6 different colors, so our degree of freedom is 5. The first result column just tells you where it's going to be displayed on the spreadsheet. We're going to come back to the shade p-value. Right now we're just going to do it without that. Actually, no, let's go ahead and do that. We'll just do it all together. Okay, what happens now is we get two things kind of squished together. Here's our information about our goodness of fit test. Here is a graph. They're crowded and hard to see, so what I'm going to do is split those up. So if you go to Doc, number 5, Page Layout, and number 8, Ungroup, it will split these into 2 different pages so they're easier to read. Now if we scroll over to where we've displayed our results. Okay, this is interesting. It didn't do this to me last time, but let's kind of make this a little bit narrower so we can see all of this more easily. Okay. So what we have here is the title of the test, chi-squared goodness of fit. We have what's called the chi-squared value, our chi-squared test statistic, which we'll talk about more in just a minute. We have our p-value, which we interpret like any other p-value. You can see this is a very large p-value, our degree of freedom, and then we have what's called our, I don't know what I did here, our components list. And we'll look at these components lists and where they came from. And then we'll look at the graph in just a minute. So let's think about where this thing came from, this chi-squared value and these components. If we want to find the components, we're going to be looking at our chi-squared formula. So let's go back and look at that again. The observed value minus the expected value gives you the what's called the residual, like we always do. The difference between what we expect, or the model, and the actual data values gives us residual. So this would be residual, and a residual, observed minus the expected. When we add up all the residuals, we always end up with 0, so we square them to get all positive numbers, and we're going to be adding those up. But the observed and the expected values, we want to, because we have all different amounts in different columns and different percentage, and we want to standardize these in some way. So the way we do this is we do observed minus expected squared divided by expected, which is very similar to a percent error. That looks very similar, except we would use absolute value with percent error. And this gives us our standardized cell components. Then we add those up, and that gives us our chi-squared value for the test. So let's just see how this works with the values that we have. So if we wanted to calculate our cell components, oops, let me type that different. So if we want our components, oh my gosh. Okay, what we would do is we say equals, and we would do a fraction here. Oh no, actually not yet. Let me escape out of that. Try this again. It's the sum. No, that's right. I just want to know the components, not the sum yet. So I would do a fraction. And each component is the observed minus the expected squared. Well, our observed are the M&Ms. Notice we have a lot of stuff in here because we did that stat test. M&Ms minus our expected values, which are the expected counts. And then we'll square this, and then divide it by the expected count. For some reason it's not letting me do that, so we'll just put expected counts. Okay, and we enter, and notice that these are the same values we get with the component list. You can see the 2.63 is the first value, the 0.435, the 0.855, etc. So these when you do the test, these components, observed minus expected squared divided by expected, are calculated for you and stored in this component list. So all you have to do is hover over it, and it gives you all these values. Now, the chi-squared value is the sum of the components. So if I just do the same little trick, equals sum, and instead of putting, now pick out the components list, enter. Okay, there's my chi-squared value, same value that I just got here. Okay, so that's where it comes from. Now what about this graph over here? What does that tell us? Well, the graph shows us our model, our chi-squared model. Unlike a normal model or a T model, a chi-squared model is not symmetric. It is always skewed to the right. The p-value still represents the area under the curve beyond our test statistic. In this case, our test statistic is the chi-squared statistic. The exact shape and spread of the chi-squared graph depends on the degree of freedom. So this is a model, chi-squared model with 5 degrees of freedom. If we look at the area under the curve that is to the right of 4.5811, the area under the curve is 0.4691. So it would not be at all unusual to get a chi-squared value of 4.5811 from our M&M's data if our null hypothesis, the manufacturer's percentages, are correct. So we cannot reject our null hypothesis. We can't say that the percentages show that our results contradict the percentages that are claimed by the manufacturer. So in other words, our results are consistent with the results, with the percentages claimed by the manufacturer. Now, we can't accept our null hypothesis as true. The best we can say is that our results are consistent with our null hypothesis, that we cannot reject our null hypothesis and say it's false. So this gives you a lot of good information. You don't have to make the graph. You can do it without checking the little box. You could also do the chi-squared test on a calculator page. So let's just look at how that would look. So if we go to a calculator page, go to Menu, Statistics, Stat Tests, and our number 7 chi-squared goodness fit test. Notice that does not give us the option of doing the graph, but we put in the other 3 things and we can push OK, and then it gives us this information. If to see the component list, you also don't have the advantage of just being able to scroll to the component list. However, if you go to the stat results and you go to stat component list and push enter, then you can see them. So that's another way to display the results. So hopefully this has been helpful to you. This is something you're going to have to be able to do for a chi-squared goodness of fit test.